All right, today we are going to be talking about the Pythagorean theorem. Now, the first thing you need to know about this theorem is that it works with only right triangles. And then the theorem itself is listed right here. A squared plus B squared equals C squared. So now we look over to the side and we have a right triangle. And we're going to label the A, B, and C. So if we read on, it says A and B are legs, and the legs must touch the right triangle box. So here's my little 90 degrees. I'll outline that in blue. There's my little 90-degree box. So if it must touch it, then that means the bottom, which I'm outlining in green, and the side here, which I'm outlining in green, those two sides touch your right angle box, so that makes them A and B. I don't care which one you call A, which one you call B, that's up to you. I'm just going to go A on the side and B on the bottom. C is a hypotenuse, and hypotenuse means the longest or biggest side. And to figure that out, if you can't tell from the picture, it says it's always across from the right angle box. So across from our right angle box would be this line over here in pink, and I'm going to label that as C. Okay, so that's the first thing you have to do. When you look at our next example, you have to be able to figure out what's A, what's B, and what's C. So let's scroll and get to work. Okay. I always start with C. Okay? So find your 90-degree box. Across from your 90-degree box is C. So that means X is C. So the other two sides are A and B. Doesn't matter which one you call what. So I'm just going to call A the 4 and B the 7. So remember our formula, A squared plus B squared equals C squared. So now plug in. So 4 squared plus 7 squared equals C squared. So now on my calculator, I'm going to type in 4 squared, which is 16, plus 7 squared, which is 49. And then 16 plus 49 is 65. And then here's the tricky part. To get from C squared down to just C, you have to know what is the opposite of power of 2. So the opposite of a power of 2 is a square root. So I'm going to put a square root on both sides. Now on your calculator, the square root, if you have one that's like mine, is located above the x squared key. So you will hit second x squared, and then your square root symbol shows up. And then type in 65. And you're going to get 8.062, yada, 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 yada. We're going to go ahead and just round these to the tenths. So then this would round to 8.1. Okay, go to the next one. On this one, cross from the 90-degree box is C. So that makes 12 my C. And then I'm just going to call 8 my A, and X is my B. So I'm going to have 8 squared plus B squared, because that's where my X is, equals 12 squared. Now, if you wanted to say X squared instead of B squared, that's fine. 8 squared is 64. Plus B squared equals 12 squared is 144. Get B squared by itself, so subtract 64 on both sides. So I get B squared equals 80. Then square root both sides. And the square root of 80 is going to give me 8.944, yada, 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 which will round to the tenths of 8.9. Okay, pause the video and you try the last one by yourself. And this time I got it to work out nice and neat, so make sure you got the answer to be 55. Okay, example number 2. This time, instead of me giving you a picture, I'm just going to tell you 2 of the side lengths, and your job is to find the missing one. So on this problem, we know A and C. So I'm going to do 6.5 squared plus B squared, because they don't give us B, equals 9.9 squared. So then I'm going to do 6.5 squared on my calculator, which is 42.25, plus B squared equals 9.9 squared, which is 98.01. Sorry, that should be a 1. Then we have to subtract 42.25 from both sides. So I get B squared equals 55.76. Then I'm going to square root both sides. And when I round it, it'll round to 7.5. Okay, next one. I know A and B. So 35 squared plus 12 squared equals C squared. So 35 squared is 1,225 plus 12 squared is 144 equals C squared. Add these together and I get 1,369 equals C squared. Square root both sides. And I get C to equal a nice neat number of 37. All right, pause the video and you try the next one. And when I round it, I get 4.6. Okay, the last example. This one, you're going to be given 3 different values for the sides, and your job is to figure out, will these 3 sides form a right triangle, yes or no? To form a right triangle, the Pythagorean theorem must be true. Okay, so A squared plus B squared must equal C squared. Now remember, up above, we said C was the hypotenuse, and the hypotenuse is the longest side. So that means C is the biggest number. So in my set of 3 numbers, look for the biggest one, and that is C. So C is 18. The other 2 numbers are A and B. Doesn't matter which one you call what, but I'm going to call 8A and 16B. So 8 squared plus 16 squared. And then I'm going to put question mark because I want to know, does it really equal 18 squared. So 8 squared is 64, plus 16 squared is 256. Add those together and you get 320. Then on the other side, I'm going to do 18 squared, and 18 squared is 324. So does 320 equal 324? You're going to say, nope, they are not equal because it's not the exact same number. So that means, therefore, no, we cannot form a right triangle. Okay, next one. The largest number is 15, so that's C. So I'm going to call A 9 and B 12. So 9 squared plus 12 squared, question mark, does it really equal 15 squared? So 9 squared is 81, plus 12 squared is 144. Add those together and you get 225. Then 15 squared. 15 squared is 225. Oh, 225 is 225. Those are equal because it's the same number. So then we get to say, yes, we could form a right triangle. Okay, you pause the video and try the last one by yourself. And then I got the last one to be yes. And that's it.